Prasad sir, Rashekar here.
Sir, good morning.
Sir, we will start, sir. Let me introduce you formally for a minute or 2 minutes. Right, sir?
Okay.
So very good morning, one and all. We are back again for the second session of fourth faculty development program titled Green Technology and Sustainability Engineering. Today we have Dr. Balla Srinivasa Prasad with us. Professor is going to present on a topic titled Development and Implementation of Online Adaptive Controller Design for CNC Milling. So presently, Dr. Balla Srinivasa Prasad is working as an associate professor at the GITAM Institute of Technology, GITAM deemed to be university at Visakhapatnam main campus. Professor's research areas includes, there are many more to mention. Let me introduce like machine tool condition monitoring, surface texture analysis, vibration signal analysis, finite element simulation of machining process, etc. So Professor Dr. Balla Srinivasa Prasad always keeps himself busy in engaging with so many international and national level conferences. He delivered lectures across the world at various reputed conferences and workshops also. If I brief about Professor's experience in teaching as well as research, Professor Balla Srinivasa Prasad holds a teaching experience of about 21 years, and he has published papers, more than 60 papers in different reputed international journals like SCA, SCIE, and Scopus Index journals, and at many conferences also. And Professor Prasad is also holding 13 PhD guidances. Out of 13, he has already 3 have been already awarded, and 10 are about to complete. And he has already guided MTech thesis for about 30, and he attended international webinar series at various prestigious platforms. And he also shown his curiosity in conducting various national and international level workshops at the university level, and sponsored by a renowned government organizations, includes like TechWhip, and in addition to the GITAM also. And he delivered like one of the reputed naval defense laboratory at Visakhapatnam, renowned as NSTL. So he has delivered so many lectures for the now NSTL also. And he has got scholarly citations around 250 with I-10 index 8 and H index as 9. And in addition to all these things, Professor Prasad has also authored many books and monographs published in various reputed publications, some of them to mention like Lambert, Germany with ISBN numbers, many are there. So today we are very happy to have Dr. Prasad as the speaker for the second session of today's faculty development program. Once again, I welcome Dr. Srinivasa Prasad to this platform. Looking forward to enjoy his knowledge that he has gained during his past research experience, and it's going on still. So once again, from the Department of Mechanical Engineering, I wish to extend a warm welcome to Dr. Balla Srinivasa Prasad on this platform. Thank you, sir. I welcome you once again for this session. So wish all participants are eagerly looking forward to receive your inputs, and definitely would help a lot in their research areas and matching your research topic today. Thank you, sir. Thank you once again. Now I request Dr. Prasad to please share his presentation. May start the session. Thank you, sir.
Okay. Thank you, Dr. Rashekar, for your very good introduction about me. Thank you very much. I'll start the session, sir.
Yes, sir.
So a very good morning to everyone. So welcome to the members of organizing committee. AACT sponsored, Atal Academy sponsored online FDP on green technology and sustainability engineering. And very good morning to participants also. I'm Dr. Srinivasa from GITAM Visakhapatnam campus. First of all, I would like to thank HOD of Mechanical Engineering, School of Technology, Bangalore campus, and my close friend, Dr. Rajshekhar, for choosing me as one of the resource person for this particular invited talk as part of AACT Atal program. Thank you very much, sir. And please convey my regards to HOD Mechanical Engineering, Bangalore campus also.
Sure, thank you, sir.
No, hopefully I will try to fulfill your requirement. I will try to reach up to your expectations. And today, my talk is all about development and implementation of in-situ adaptive controller, design and its implementation. As it is a research program, I'm confining to a specific field, milling. Even though this particular concept is going to give the scope of implementing the same logic with the minor variations to more than one type of machining application. But as it is a research application, I need to confine to one specific problem. I will try to go to the as deep as possible. I will try to give the all details about this particular application. Now, we would like to, I would like to justify each and every terminology which is associated with the title. And I'm presenting this particular topic as part of the smart and green manufacturing area of this particular program, FDP program. So before going to the topic, we are all engineers. I would like to recollect some of the definitions, the popular definition, or we'll try to relate with this particular concept. So irrespective of the branch of engineering, every engineer will try to convert his ideas into reality. If that can be done in an effective way, only one stream can do that. That is nothing but engineering. Again, coming to the fulfilling the needs of the society, if that is the object of any stream, if any stream is capable of fulfilling the needs of the society across the world in a best possible way, at the cost of it is the criteria. Only one stream can give the solution, that is again the engineering. Irrespective of the branch of engineering, we all try to give the better comfort to the mankind at the cheapest possible price. And this particular process is not going to end today. It is a continuous process. That is why if you search some keyword in the Google, every second, for every hit, you'll find the difference in availability of the information. So research has no limits and research has no stop also. Every second you will find new inventions. Now, basically, engineering is all about practical application of science and mathematics. Whatever you do, irrespective of the branch, we will try to give all the needs of the society at the cheapest possible price with as far as possible. Every day we'll try to, human brain is a highly dynamic. Human brain needs a new item in every day. In fact, every second. Only one stream can attack that. Only one stream can defend this. That is engineering. So you must be proud about being an engineer, irrespective of the branch. Now, is there any best place? Because I'm representing my university, I'm taking one or two slides to represent about my university because it is part of my duty also. Is there any best place to start with to pursue your dreams as an engineer? Is there any institute which is committed to excellence in imparting the technical institution? There is no other way, the GITAM. Irrespective of the campus you have selected, it is assured you will get the best possible education for your dreams. It can be undergraduation, it can be post-graduation, it can be PhD. GITAM is going to give the best possible atmosphere in India. Now, so outlines are my presentation. So I'm supposed to present this particular topic. It is about design and development of a adapter controller design for the CNC milling. I'm going to present the details out of this, but why it is coming to this particular subsection of this particular FDP. So people are talking about the green manufacturing and smart manufacturing. First, we need to understand the basic, only the fundamental differences between the meaning of the green manufacturing and the smart manufacturing. Now, if any manufacturing process which emits less amount of emissions out of its regular activities, it comes under a green manufacturing. If any production process which involves assembly as an integral part of the activity, that comes under manufacturing. If any production process which does not involve assembly, that comes under primary industry or the product industry. Now, coming to the all automobile sectors involves assembly as a compulsory activity. All automobile sectors involves secondary manufacturing process. All production industries like steel plants involves does not involve the assembly. So, if I talk about manufacturing, it means it is consisting assembly as an integral part of this particular production process. Production is different, manufacturing is different. Even though they look similar, even though in a broader sense they can be represented in a one subgroup of the mechanical engineering, but they are literally they are different. So what is a smart manufacturing? So nowadays everybody is talking about artificial intelligence and machine learning. Before going discussing about the artificial intelligence and machine learning, we need to understand what a machine can be automated beyond CNC machine. CNC operation is about giving some input instructions in the form of part programming. If that particular program is understood and interpreted by a machine controller, if it is repeating this task, whatever you are expecting it to repeat the operations of the 3 different axes or 2 axes or 5 axes in some cases, that is called execution of the part programming. If it is done with the help of only NC part programming, that comes under numerical control. If it is extended up beyond NC part program, that comes in the CNC manufacturing, CNC machining. If something is to be discussed, something can be done beyond CNC machining, maybe those things will come under smart manufacturing. Now, smart manufacturing means if you are able to make a communication between a device which can collect the information during the machining. For example, when I see, if you talk about CNC milling or drilling or turning operation, based on your input instructions, it is going to operate it. It is supposed to remove the material from the given stock. Is my voice audible? Can anyone please confirm?
Yes, sir. Yes, sir. It is audible.
Okay.
It's clear, sir.
Okay, done. So, as per the instructions in the program, it is supposed to remove material from the given stock. During this particular process, if you ignore the amount of the forces which are developing while remove the material, if you are not focusing on the amount of the temperatures which are developing as part of the remove the workpiece during the process of chip removal, when there is an unmonitored output process variables, if the output process variables are left alone without considering its effect out of the machining process, they can lead to a very bad impacts on the total life of the machine or the machine quality in the machining. So in general, the quality of the machining will be expressed in terms of the surface roughness of the finished product. But this particular surface roughness is 100% related with or influenced by the or promoted by the output process variables like forces in the cutting, deflections in the spindle or the workpiece, surface roughness, excessive temperatures. These things are not given by the operator. These things are outputs because of the amount of the input parameters you have selected to carry out that particular operation with an objective to give the required shape of the object as per the part drawing. It means the CNC machine is going to act, is ready to work based on the 3D model or 2D model. It is going to detect features from the drawing, and this particular CNC machines nowadays are capable of extracting the features from the part drawing, and they are able to generate the part programming codes based on the part geometry features. CNC machines is able to understand the program, they're able to repeat the task. But there is no system is available which can regulate the machining process based on the output process information, which is evident in every machining process, irrespective of the application. It can be drilling, milling, turning, whatever may be the machining process, secondary manufacturing process, which involves material removal is a must. If material removal is not a must, that comes under primary manufacturing process. If the material removal process is supposed to be handled with the help of programming control, that comes under CNC machining. If the output process variables is taken into consideration to regulate the process, to safeguard the machinery, to safeguard the equipment, to yield better results, to give quality products, then it must be something beyond CNC operation. It comes under a real-time process monitoring. If this particular real-time process monitoring is done with the help of some sensors, if you are able to incorporate a sensor, if you are able to establish a sensor, communication between the sensor and the CNC machine controller, if the sensor is able to collect the data based on the information what you have collected from the sensor, if you are able to change the input instruction for CNC operation without switching off the machine, then it is something called as a smart manufacturing. Again, some sub-classification is there. Establishing a communication between the sensor and the CNC machine and the CNC programming controller. If that is done at the machine's place at the shop floor, that comes under embedded system. Now, whatever the decision, whether to increase the speed, whether to decrease the speed, whether to increase the feed rate, whether to decrease the feed rate, or change the depth of cut, replacement of the cutting tool, whatever may be the decision, if the decisions are made at the machine place, with the computational logic you have developed at the machine place, if that logic is, the decision is made at the shop floor, if the decisions are confined to only one machine, that comes under embedded system. Now, coming to another system, if the sensor and the CNC machine, sometimes more than one sensor, multiple sensor, multi-sensor, contact sensor, non-contact sensor, irrespective of the sensor, if the sensor and the CNC machine, if they are able to connect it through internet, then the concept is known as IoT, Internet of Things. Both CNC machine, sensors, it can be one or two, everything will be connected over a net, and you will get the information while machining is in running condition at your laptop or mobile. That is about collecting the information on your required smart devices. Again, taking a decision about changing the input instructions. Once the input instructions are changed, automatically the part program which is required to operate the CNC machine will automatically change. If this change in operations and the followed by the change in part program is happening based on the decision made on the cloud, then the concept is known as IIoT, Industrial Internet of Things. It can be embedded system, IoT, IIoT, everything comes under smart manufacturing system. Today, I'm going to present a system under smart manufacturing at the first category. So I hope my topic will be justified to be presented as part of this particular session. And it is the subsection of this particular session is known as green technology and smart manufacturing. And the operation, the example I am going to present today, it does not consume the coolant. I have not used the coolant. Everything was carried out under a dry machining condition. Actually, that is a limitation of my study. See, I'm trying to use the more than one sensor. In that particular sensor, those sensors, if they're submerged in any coolant, they are not going to work in a better way. That is why I have avoided using the coolant, so that whenever I am able to eliminate the coolant, there is no question of emissions. Even though the coolant, if whenever the coolant comes in contact with the workpiece and the cutting tool during the machining, due to the amount of the revolutions and the friction, amount of the forces, automatically some fumes will come. They can create unwanted experiences or unwanted atmosphere emissions. So when there is no coolant, I need not think about emissions also. So that is why this particular topic is related to both the green manufacturing and the smart manufacturing. No. So my presentation is going to consist about uh, the details of the work. As part of my title, it is all about developing a controller which works It works in an adaptive way according to the situation. And for this particular problem, I need to define the problem based on out of my literature survey. I'm not going to present the literature because due to shortage of time. Based on the literature, I have identified some gaps. Those gaps will be the targets of my presentation. They are represented as objectives. To achieve these particular objectives, I need to select an experimental setup. Then I need to design an experiment to how to utilize the setup in an optimum way. What are the minimum number of trials so that the required output can be achieved? For that particular purpose, I need to go for the design of experiments. So then I need to give details about, I'm going to give details about the major equipment which is procured under the funding of Government of India. That is, I have used this particular equipment as part of my DST project, DST funded project. And those objectives are achieved through a methodology adopted or suggested by this particular output. I'm going to give the details about the proposal methodology. And the controller, adaptive controller is designed in nearly 6 different steps. Each and every step will be discussed in the presentation. And I'm going to give the details about how a signal can be analyzed, how an information can be entered into the system as a layman or an operator at the particular machine. Each and every detail I'm going to give with a real-time working experience. Okay. So as I mentioned, forget about whether it is smart or conventional, it is a machining. You treat this as a machining. Irrespective of the type of machining, these are the factors that affect the cutting tool condition in the machining. First of all, tool material, cutting parameters like cutting speed, which will be expressed in meters per minute. If you want to express in terms of RPM, definitely you can do, but you need to consider the diameter of the cutter and the feed rate, depth of cut, workpiece material, cutting operation type, coolant, tool holders, machine stability. Every machine inherently, by default, OEM, the manufacturer is going to specify about its limits. Whenever you are pushing that particular stability limit, then the machine will start giving the unwanted expressions. It is started giving its responses. Now you need to capture the responses and you need to understand the responses. So even though you are able to visualize the responses, sometimes you are able to hear the particular responses, but your visibility or audible, you are able to listen. This particular facility does not give you any quantified information. To get it quantified, you need to take the help from the sensors. Executing the machine process may not be the greatest thing nowadays. If anybody who can prepare the part program, the machine will work. But how to safeguard the machinery? If you talk about production machines, their minimum cost starts with 50 lakhs and above. If you consider any institute, it can be university or institute, premier institution, they can spend 50 lakhs once in a lifetime. Maybe this particular investment of 50 lakhs, they're expecting to for about next 50 years. That is a general perception of any institute. So as a faculty, as a researcher, you need to identify a methodology, or you need to identify a develop system so that you can safeguard the machinery. It is not with respect, because why I am taking this particular example as institute. As a faculty, our responsibility to safeguard the machinery. If you consider it is an industrial application, if the machines are not processed, not maintained properly, if they go for breakdown, it is automatically reducing the profits. So to make sure every machine is ready to work in every time, you need to you need to maintain the machine in a better possible way, in a scientific way. Whatever the suggestion you are going to make, that must be out of the scientific logic. Otherwise, it is a trial and error method. So that is why this justification is required. So these are, if these persons are affecting the life of the cutting tool, then you need to identify what could be the output variables. Then we'll try to use one sensor so that you can capture particular information. If you are able to collect the information of the output process variable, it can be forces in the cutting, it can be chip formation, stresses and strains during the chip formation, it can be power consumption, it can be temperatures during the cutting, it can be tool life, it can be tool vibrations. Now, if I talk about the tool life, it will be expressed in terms of tool wear. To measure this particular thing in direct method, you need to switch on the machine, take out the cutting tool. It can be single point or multi-point. Then only you are allowed to inspect the tool wear. If we talk about power consumption, it is an output process variable. The amount of forces, amount of the input parameters, the power consumption will vary. Amount of the hardness of the workpiece, it is encountered during the cutting, during the material removal. It is going to affect the power consumption level. Definitely. See, while giving input instructions, you may not consider all the factors, but these are the factors. It can be forces, temperatures, deflections, tool wear, whatever may be the things, they will be available as an output process variables. In a open loop machining system, these factors are ignored. They will not worry about these particular outputs or variables. Their intention is to execute the task, produce the part. That machine is not intended to produce only one production lot, 1,000 items per year. That is not the objective behind procuring and spending that much of money. It is the main object is to safeguard the machinery. So that can be done with the spending some time on focusing on the outputs for variables. If you are able to suggest anything out of the outputs process variables, then it is an added advantage to the life of the particular machine. And it is going to influence the quality of the machining in the form of surface roughness, which is available on the produced parts. It can be surface roughness, it can be flank wear, both require stoppage of the machinery. Then only you are able to take out the workpiece from the top, or you are able to remove the cutting tool from the spindle. Now, stopping of the machinery, removal of the cutting tool, or removal of the workpiece consumes a lot of time. If this particular process is handled when the machining is in running condition, again it will be an added advantage. Now, few factors are going to influence the cutting tool, and the factors that are affected by the tool wear during the machining. So tool wear is considered as a judging parameter with respect to the quality of the cutting tool, whether this particular tool is allowed for the machining or not. You have collected the information after half an hour or 10 minutes or 20 minutes, then you'll get some information about the life of the cutting tool. What is the wear rate? What is the value of the tool wear? Then you need to decide whether this particular tool is allowed for further machining. If you continue with the same cutting tool, it automatically generates scratches on the workpiece. That is, once the scratches are generated on the workpiece, because it has reduced the quality of the surface. So surface roughness, plank wear, they are 100% interrelated with the forces in the cutting, temperatures, power consumption, and the deflection. So, for example, consider this as a single point cutting tool. Based on its VC value, that is meters per minute, machining time, cutting speed. When it is kept on the spindle, it will start rotate with some RPM. It can be 3-axis machining, it can be 2-axis machining. In 3-axis machining, cutter will be rotating condition, and 2-axis machining, workpiece will be in rotating conditions. When there is no interaction between workpiece in this direction, in case of 2-axis machining, that is lathe operation, boring operation. In case of 3-axis machining, drilling, milling, as long as there is no interaction with the workpiece, this particular spindle is going to yield almost negligible deflections. And this particular spindle in 2-axis is going to yield very less amount of deflections. They are not going to affect anything with respect to the stability of the machine or condition of the machine. As long as they are interacting with the workpiece in a process of remove the material from the workpiece, it will start experiencing some amount of friction. This amount of friction is required so that it can start remove the material. Along with the amount of the friction, the forces, the quantity of the amount of the forces will vary, and these forces are responsible for the temperature, raising the temperature at the tool tip interface. It can be here, it can be here. Now, as part of this presentation is concerned, it is going to suggest a solution based on the feedback collected in the form of vibrations. Why I have considered vibrations as a feedback here in this particular system is, if you go through the literature, if you talk about the research in the machining part, most of the researchers have done with the cutting forces. And every time, most of the researchers, RA is the most popular parameter in judging the quality of the machining, surface roughness, RA. One is with respect to workpiece, that is plank wear. One is with respect to produced part, that is RA. Another one is during the machining process, that is cutting forces, and power consumption, tool tip temperature. So if you consider the temperature, generally thermocouples are used to capture the temperatures. That is in contact mode. If the coolant is used, there is no need to measure the temperatures. So whenever there is a temperature rise, automatically the coolant is going to suppress the amount of effect of the temperatures. Now, once a coolant is involved, even though they are suppressing the temperature, during this particular process, it can generate some smoke, unwanted emissions. It can be vegetable oil. The coolant can be mixed with the nanoparticles. They may exhibit some different, depends upon the mixer. It is going to exhibit some different types of emissions. They can be good or bad to the society or the environment. So that is not the case in this particular case, because we have preferred a dry machining system. So you need to judge the machining based on the plank wear values. This particular judgment will be taking place out of this particular presentation based on the amount of signals we have collected as a vibration parameter. So I have designed a system. It is going to act according to the amount of vibration present in the system. And if you talk about any academic institution, the maximum rotational speed we will allow our students to inspect or carry out their experiments is generally up to 2000 RPM. Any rare cases will allow the students, undergraduate students or PG students, to go up to 3000 RPM or less than 4000 RPM. So as part of this particular presentation, I am going to give a scope on working beyond 10,000 RPM. The machine we have procured as part of the DST funding is capable of working up to 18,000 RPM. Now, so my concept is adaptive controller design is going to work based on the amount of the vibrations present during the machining operation. So the whatever the logic I'm going to suggest, whatever the decision I'm going to take out of this particular work are based on the vibration signals only. That is why I'm spending 1 or 2 minutes on giving the brief details about the vibrations. I'm not going into the complete detail. It is almost impossible to everyone. I mean, it is impossible for me to convey. Even I did not gone through the certain level, beyond certain level of this particular concept. It is an ocean. If we talk about vibration, it is present everywhere. And I'm trying to use the concept of vibration, and I have incorporated this particular information in a decision making. Now, vibration is a movement of a body about its reference position due to excitation force that causes the motion. That is what we have discussed. When there is no interaction, there will not be any vibration. When there is an interaction, automatically it will start vibrate. Deviate from its required position. That is called the deflection. It is supposed to be rotate in this direction on the x-axis. When there is an interaction, it will start deflect from the required position. This particular amount of deflection must be captured with respect to time scale. That is the concept of the study. For a time period, it can be 5 seconds or 10 seconds. You need to capture this particular amount of deflection. If you are able to identify there is an amount of deflection, it means you have identified there is an amplitude of vibration is present in the system, in the machining, in the signal you have captured. But still, that is not sufficient to go ahead. You need to quantify the vibration signal. Identifying the presence of vibration is different, and quantifying the vibration is different. You can express the amount of the vibration in 3 ways. One is velocity, acceleration, and displacement. Displacement will be expressed in terms of microns. And if the displacement, I mean the amplitude is considered 0 to peak, that is called velocity. If it is considered peak to peak, that is called displacement. If we consider the RMS value, that comes under acceleration. These are the 3 ways you can express the amount of vibration. Initially, you will capture the amount of vibration on the time scale. For a time period, you can adopt any sensor. You can use any sensor. It is going to give collect the information. Data, that is called data acquisition through sensor. Quantifying the signal, that can be done with signal transformation functions. I have used 2 different signal transformation functions out of this particular presentation. I'm going to show the clear difference between 2 different transformation functions. Now, there are 2 important aspects that is to be remembered forever if you are working in the vibration. If you are interested to do anything related to the vibration, 2 statements to be remembered forever. Vibration amplitude indicates the severity of the problem. If you consider this from peak to peak, definitely it is going to indicate the presence of the vibration, at the same time severity of the vibration. Now, the same severity is occurring how many times per second? That is called the frequency. Vibration frequency indicates the source of the problem. At what frequency? Is it 1000 frequency, and is it 60 hertz or 30 hertz or 40 hertz? At what frequency the same problem is repeating? That is called the frequency indicates the source of the problem, and the amplitude is going to indicate the severity of the problem. Severity is also important, and the frequency also important. Source of the problem also important, because if you're able to identify the source of the problem, we can regulate, we can give some solution to avoid that occurrence again. There is a possibility of giving a solution out of the identification of the source of the problem. Whenever you place the situation, unwanted situation, then you need to measure how much this is it acceptable or not? That is where the quantification is required. That is where the vibration amplitude helps. So if I talk about if my decisions are made based on the values of the displacement, values of the velocity, values of the acceleration, then I need to quantify it. It is a must. Then only whether this particular amount of displacement is acceptable or not. That particular decision must be taken based on that. The adaptive control system must work. So I need some guidelines where it is available. That will be discussed in the next slide. So for quantification, amplitude is required. After quantification, that particular values will be compared with the allowable standards, which are accepted by all the industrial applications in the world. They are ISO standards, International Standards for Organization. That particular severity of the displacement or velocity or acceleration is coming at what is experiencing at which frequency. If I am able to identify the frequency, then I will try to avoid that particular situation in the next stage. Or we will try to adapt to some methodology so that you can delay this particular occurrence. That is how we can safeguard the machinery. This is where this terminology is related to this particular field of application, or anybody who is working in the field of vibration, particularly if you're thinking to do some explore something related to machining, this particular slide is very much useful. So these things must be very clear before starting taking up the research in the field of machining with the help of vibrations as a supporting tool. Now, when to identify, how to identify which is good vibration or bad vibration. So regenerative vibrations are called chatter. Coming to the vibrations in the machining, regenerative chatter is called as a vibration, and it will happen. Every system, every rotating system will be given some natural frequency. And you will try to operate the same system. You will try to operate the same spindle. It can be vertical in case of 3D, 3-axis machining. It can be workpiece in the turning machine. You will try to operate according to your requirement, according to your choice of input parameters. Depends upon the cutting speed you have selected. The driving force, the spindle will start rotating as per the instruction given by you as part of the part program. Whenever this rotating, given this particular driving frequency, which is running according to your input instructions, whenever this particular frequency of the given or programmed frequency matches with the natural frequency, then the resonance will occur. That is where you will identify these peaks. This is called the waviness. Remember, whenever natural frequency matches with the driving frequency, resonance will occur. That is where you will experience the regenerative chatter, excessive sound. You cannot hear with your ears. Now, and coming to the resonance. This particular resonance is a result of external force. We are not running the machine according to the suggestions given by the manufacturer. You are trying to operate the machine according to your input parameters. The input parameters selected by you out of your research, out of your requirement, out of your pressure or something else. If the input instructions given by you in the form of part program, if they're able to do something with the machine, poking the machine, it automatically creates a external force on the machine. This particular force is going to generate. The machine should exhibit its unwantedness. It is not taking that particular information which is given by you. It is unable to swallow the input parameters given by you. It should exhibit in some other way. Generally, without real-time process monitoring, the operators or manufacturers or the people who are controlling at that particular helm, they will try to ignore this particular output process variables. The machine is trying to express something, its unwillingness. And the condition monitoring is the like a doctor to the machine. It is ready to hear. It is ready to listen. It is ready to touch. It is ready to give solution. Whenever you are facing some temperature beyond 98.6 degrees Fahrenheit, it can start with Dolo 650. If something beyond 103 degrees, automatically it will be shifted to quarantine. So machine is trying to give some information. The condition monitoring is the doctor to the machine. It is trying to change the information from the vibration signals rather than the thermometer. It is taking the information in the form of vibration signals. Then it is going to give some suggestions. This particular machine is not able to take that much of RPM. This particular machine is unable to take that much of feed rate. This machine is very much safe. You can give extra load. This machine is capable of taking much load. It is working only up to 2000 RPM. This machine is capable of running 5000 RPM, 6000 RPM. That is how you can assess the situations at the machine's output with the help of output process variables. As part of this presentation is concerned, I have considered only the output parameter as a vibration as a output process parameter. What are the suggestions I'm suggesting based on the output parameter, which is considered a vibration parameter? All others can be considered. My intention of showing the third slide is to give the scope of research in the field of manufacturing, particularly in the machining. As a research, I need to go very specific to a particular problem. I'm trying to give a solution with the help of vibrations as a feedback signal, where you can attack your problem or you can develop your problem by considering the all other parameters which are listed in the third slide. Select a few from them. If you attack everything, you will end up writing the textbook, not the research thesis. If you want to contribute significantly towards a field of your research, go narrow, select a few parameters and contribute significantly. So it's up to you to decide whether you're interested to write a textbook or the research thesis. So again, decision is left with us. Now, so I think I understood. Condition monitoring, the solution is going to act as a doctor to the machine. The natural frequency is a characteristic of every machine and the structure. And the fundamental frequency is another important terminology, most commonly used terminology in each and every research publications which are available on the vibrations in the machining is it is the lowest natural frequency of a vibrating system. You can set the first signal, first peak. That is generally out of the initial interaction of the workpiece and the cutting tool. That particular signal must be ignored. You are supposed to take the signal after reaching the steady state. Then only you will get the consistent results. So initially, after touching the workpiece with the cutting tool, immediately you can observe if the cutting force dynamometer is attached to that, you can find maximum amount of forces. Actually, that is not the forces in the cutting. After allowing the system to run for quite some time, then only take the signal. So avoid the first signal. So this is about basics of the vibration and the particularly machining vibrations. So these two must be keep that in mind if you are planning your research in the field of machining with the help of vibrations. Coming to the adaptive control. So far, I have presented the basics, the fundamentals, the key points associated with my field of application. You can consider the basis for this particular approach, that is adaptive controller design. Now, as we mentioned in the third slide, every machine process will have the speed, feed, depth of cut as a basic input parameters. If you want to consider cutting tool material property as one of the parameters, you can consider. If you want to consider the hardness of the workpiece material, you can also include that in designing the experiment. But along with the speed, feed, depth of cut, workpiece, hardness, cutting tool, angst modulus, whatever may the parameter you wish to include, you can include. Based on that, you can design the experiment. By involving the minimum 3 parameters or many parameters as input parameters, irrespective of the amount of the input parameters, the output process variables are common. forces in cutting, torque, cutting temperature, horsepower, and spindle deflections or vibration during the machining. Now, these things must be given focus. If they're understood properly, if the information which is collected as form of the output process variables, if they're used in a right way, there is a lot of scope for safeguarding machinery and improving the productivity of the process. There is a possibility of reducing the cost. If you are able to reducing the cost of the whole process, it automatically increases the profits to the organization. Now, as I told you, adaptive control system is going to give a solution without switching off the machine. If that is able to done, coming to the third advantage, reduce the manufacturing machining lead time. It is going to reduce the total manufacturing lead time. Now, coming to the definition of the adaptive control system, adaptive control measures the certain output process variables. It measures the cutting forces, it can measure torque, it can measure temperature, it can measure horsepower, it can measure vibrations, and uses these output process variables to control speed, feed, depth of cut while machining is in condition, working condition, running condition. It means adaptive control is going to take a decision, logical decision about input parameters based on the output process variables. Just remember this statement, and this must be understood. Whenever you talk about adaptive control system, it is going to develop a system, give a solution based on output process variables about the how much feed is given, how much speed must be given, how much depth can be given, whether it can be decreased or increased, either way. But it is supposed to be implemented in a real time. This particular implementation lies in the hands of a particular keyword called sources of variabilities. It is ready to give the suggestions for increasing or decreasing of the input parameters according to the situation, according to the variability. So the adaptive control system is going to act according to the situation with respect to the variability which identified during the machining. Whenever it identifies some variation in the machining, then it is going to give the solution number 1. If not, solution number 2, solution number 3. For every variation, it is having a new set of solution. Whenever it identifies a new solution, it gives the respective suggestion, the respective program, the respective set of input parameters will be given as part program for execution of the program. Automatically, input parameters will be modified in the part program. Why I have confined input parameters as speed, feed, depth of cut in this particular application is this CNC machine is going to work on the part program. The part program is not going to take the workpiece material as an input instruction for the part program as per the syntax. If you have any idea about the CNC part program syntax or NC part program syntax, it always works on it is known as a numerical control part program because it is dominated by the numbers and alphabets. It always takes X, Y, Z, S for speed, F for feed. X, Y, Z to indicate the presence of the geometry and everything. To give the machining parameters, it takes either speed, it takes only speed and feed. Depth of cut will be indicated in the form of Z. So these parameters will be altered when there is any sources of variability is identified during the machining. So another key terminology in implementation of this particular logic of this particular work presentation is sources of variability. What is the sources of variability? Again, that will be discussed in the next slide. Now, so adaptive control systems can be applied when the following conditions are found: excessive tool vibrations, varying workpiece dimensions, gradual tool wear, uneven workpiece surface, material hardness, temperature variation during the cutting, the fixture stability, jigs and fixtures, errors in part programming. So even though we have prepared the part program, there is no guarantee it will be error free. So when there is a variation is occurring, adaptive control is ready with a solution. how it is going to give the solution, it will be understood later. Now, coming to the definition of the problem. So main objective is to design and develop a adaptive controller design. And we have considered vibrations as a parameter for judging this particular thing, because uh, even today, till now, the less amount of attention is paid in the machining with respect to the vibrations. Vibrations is a huge area, and vibration is many applications in industrial application, but very little amount of focus is paid with respect to vibrations in the machining. That is why I have selected vibrations as a decision making tool as part of this particular investigation. I'm not the first person, but I'm one of the few who have considered the vibrations as a decision-making tool to do some application with respect to the vibration in the field of machining. So that is the main intention. Now, with the help of vibrations, we would like to show the relation between the vibrations and the surface roughness. For this particular process, we need to cover a lot of vibration data. Then we need to quantify the vibration data. Then you need to select which parameter is suitable for your mathematical modeling. So as for why I have specifically mentioned about the units, displacement in microns, another two are mm per second and mm per second square, velocity and acceleration. If you know the one particular value, one is derivative, another one is integration. You will get the other two values. So if you want to define a relationship between the vibration parameter and the surface roughness, sometimes that based on the mathematical equations, sometimes it is useful to include in terms of velocity, in terms of acceleration, in terms of displacement. Depends upon the mathematical relationship. It is up to us to decide which one is going to matches with LHS left hand side with RHS right hand side with respect to units. Then consider that particular parameter. That is why I'm suggesting once collection of the vibration data is not sufficient, you need to quantify the vibration signal in three ways. Once it is available, then you can go for the mathematical modeling. Then you need to identify whether the collected or gathered or determined vibration signals are within the limits or not. How to decide whether the identified amount of vibration parameter is within the acceptable range or not. For that particular purpose, I need to cross-check the collected information with the available suggested international standards of this particular application. Now, I'm going to mention about a particular standard in the later stage, that is ISO 10816. If you're interested, please make a note of this. ISO 10816-3. It is a standard which is ideally acceptable for assessing the machining vibrations. ISO 10816-3. This is exclusive for the machining purpose. It will suggest some severity charts in terms of three different parameters. Now, here the main important task is identify the amount of, collect the information about the vibration, then quantify the vibration signal, then develop the relationship between the surface roughness and the vibrations, then relate these two parameters, roughness values, vibration values, in defining the flank wear. If the flank wear is less than 0.3 mm, you can continue the machining, because it is high-speed machining. High-speed machining is going to generate the highly smooth surfaces. I can give the cutoff value of the cutting tool flank wear up to 0.6 mm. But if I give the 0.6 mm, I need to increase the acceptable range for the vibrations also. As it is a high-speed machining and the quality of the machining is very important because it is focused with the surface roughness parameter, I need to give close acceptable limits with respect to surface roughness and the vibrations. So I have considered the surface roughness and the flank wear at the judging parameters, one respect to workpiece, one with respect to cutting tool. These two parameters are used to assess the quality of the surface, assess the quality of the cutting tool. And these two parameters must be defined along with the vibration parameters. If that is done effectively, then only I can claim this particular adaptive control is going to act based on the vibration signals, because it is the vibration signals are going to act as a input parameters for defining the surface roughness and flank wear. You can reject the product which is coming out of this particular process either based on the surface roughness value, or you can stop using the cutting tool based on the flank wear value. If the information, if I am using a one particular feedback information, if that particular feedback information is able to define, is able to, if this particular vibration information is able to define RA values of surface roughness, is able to define the flank wear VB values with the help of vibration parameter, then this concept is justified. We were able to justify, and I'm going to show you everything. So what are the value of VB? It must include the values of vibration. What are the value of RA that is available on the product of the surface, surface of the product, that must involve the values of vibration. Then only this concept is justified. Now, coming to the high-speed machining and the design of experiment, now you can consider initial cutting speed is considered as the meters per minute unit that is to be converted into RPM. So we have converted up to 7,000 RPM, 12,000 RPM, 16,000 RPM. So whenever you talk about high-speed machining, if it is beyond 4,000 RPM, you just remember like that. If it is beyond 4,000 RPM, then it can be considered as a high-speed machining. For example sake, I'm saying, but there is some constraints are there for identifying the cutting speed with respect to workpiece hardness. Also, you can define whether it is high-speed machining or not. But this particular application is concerned, anything beyond 4,000 RPM is comes under high-speed machining. So the experiments we have conducted at 7,000 RPM, 12,000 RPM, 16,000 RPM. So definitely it is, whether you consider these conditions or not, it is 100% high-speed machining. Here the feed rate is expressed in terms of mm per minute, and different types of depth of cuts and different types of workpiece materials are used. And these are the variations with respect to the cutting tool, with respect to diameter of the cutting tool, with respect to the material of the cutting tool. And we have used most popular technique L9 orthogonal array. And this particular work is already, this particular figure is collected from this particular publication. And this particular number indicates DST project sanction order. So as I told, it is going to act as a, according to the situation, because it is an adaptive controller system, it requires some database. Out of the experiment, you are going to identify the different situations. Each and every situation must be recorded in an electronic way so that that decision will be made based on the interacting with the central database. So we were able to establish the communication between the database and the part programming console and the sensor by using the MATLAB. First one, objectives of this particular suggestion, work. We need to collect the data in real time. Immediate task is, once the collection is over, then quantify the signal. We are focusing on the vibration signal, then quantify the vibration signal, then identify the constraints for each and every parameter. Then this particular experiment must be designed according to the design of experiments, DOE. You can use the Minitab software for designing the experiments. Then we have identified a vibration parameter or quantified the vibration parameter. Then try to relate this particular quantified vibration parameter with the judging parameter of the cutting tool, that is tool wear. Now, once decisions are ready and the logic is ready, then try to develop a strategy. This is what I'm talking about. ISO 10816 standard. This is exclusive for the machining operations with respect to vibrations. So whenever the horsepower of the machine of certain race, so for example, 10 HP, if any machine which runs with a 10 HP or less than 10 HP, this standard can be used for comparison or evaluation. Like that, they have given 5 different sectors of different ranges of the speed, different ranges of horsepower of the machine. If you type this particular keyword in the Google, you'll get the idea about how they have classified, how they have suggested based on the power, horsepower, and rotational speed. We have considered this particular standard for decision making. We have collected the data, but decision, we were able to take some decision, but that must be approved by international organization or approved scientific community. So ISO is approved by most of the people. It has approval of throughout the world. So whatever the decision we made are in accordance with ISO 10816. And this is the equipment I have procured as part of my DST project. This is a facility which is available at GITAM main campus, Central Research Facility. And this is a 3-axis CNC machine. And the sensor we have used accelerometer Kisler model, highly sensitive piezoelectric based accelerometer we have used 8793. And it is mounted here at the spindle head. Now, it is capable of working up to 18,000 RPM. And this is where we are trying to operate the machine. The communication is established between the sensor and the control panel through RS-232 port. Whoever is working in the CNC machine, they can understand the meaning of the RS-232 port. The need of this particular port. Without the RS-232 port, you cannot transfer the information of the which is in the form of part program. It cannot be transferred to the CNC machine. This port is a must for CNC machine. So, line of instruction, one line N01 indicates some program. Set of instructions is the program. These programs must be compiled at the controller. Then the instructions will be converted into digital form. These particular information will be transferred to the servo motors, which are attached to each and every axis. Each and every servo motor will have a lead screw. It can be horizontal motion, it can be revolving, it can be other motion based on the encoders and resolvers. The information which is converted, which are readable in the form of part program, which are converted at the controller, which are transferred to the servo motors in the form of MC blocks, which will be read and interpreted by the servo motors, and the instructions will be transferred to the lead screw. Then the axis will start moving according to the input instruction you have given. So based on the, due to the presence of this particular Kisler model accelerometer, its objective is whether the machine is in running condition or not running condition. Whenever you have activated the particular icon, it will start collecting the data. Then as an operator, you need to transform this particular information into quantified vibration parameter. That must be done in a quickest possible time. We were able to transfer this particular vibration signal, targeted vibration signal, in 20 seconds into quantified vibration parameter. So, if my intention is, you can consider this as a limitation also. Due to the computational facilities available at that out of this particular project and the funding, we were able to operate this particular machine with computer with a 6 GB RAM. This particular 6 GB RAM computer, desktop computer with the MATLAB software, is able to process the signal, which consists of 1024 lines of 3 variables data in 20 seconds to identify the quantified vibration parameter. And this is the delay is required, and this we cannot avoid. And this much of delay is taking place while changing the input instructions. This is a must. You can consider it as a limitation. If anybody can do beyond this, that is, my machine is always open. You can assist me. I will take the help from you also. So every time when there is a change of instructions according to the vibration parameter identified, it is taking 20 seconds time to change the part program. This is a delay. This is inherent. Because you are all belongs to GITAM, I am conveying this. but it is able to effectively, it is able to change the input instructions. Okay. So here the important task is you need to establish a communication between a sensor, CNC machine controller, and the VDL drive. They must undergo common work under a common controls, common programming control. That particular program is developed with a MATLAB. As long as they are working effectively, the results will be very good. And to explore this particular research, we have considered 3 different workpiece materials, 2 different cutting tools, and 2 different diameters of the cutting tools also. So again, I'm repeating the same statement. We need to establish the communication between the sensor, CNC controller, and CNC controller sensor, and the VDL drive. The communication is established at the machine place, at the shop floor. That is why it is comes under embedded system. That is why this is part of smart manufacturing. And again, we have not used any coolant. That is why this is comes under green manufacturing. We are not generating any unwanted smoke. We are allowing the machine to run as per our requirement. During the operation, we are focusing on the vibration. We are able to collect the information about the vibration. Then we were able to distinguish the vibration parameter out of the signal. Now, more closer view about the various components. And this is the console where we have used it to analyze the vibration signal. If it is visible, you can identify that this is the icon. It will allows us to give the displacement, velocity, and acceleration. And this is the initial, the bottom part is initial signal. Initial signal will be collected with respect to time. You cannot justify, you cannot quantify the how much vibration is present. But this particular time domain signal is going to give the presence of vibration is there or not. It is going to give the presence of the vibration. So bottom part of the signal is going to give the whether the vibration is present or not. And this particular signal, upper part is going to give the severity of the problem. These 2 things are very much important. One is source, one is severity. If you are able to identify this particular acceleration at this particular frequency, if this particular frequency and the value of the acceleration is acceptable by the ISO 10816, there is no problem. You can continue the program. You can continue the machining. There is no need to change the input parameters. Whenever this particular conversion of this particular signal identifies a value which is not acceptable according to the suggestions of the ISO 10816, then this system needs some change of input instructions. If you ignore this particular amount of vibrations, whether they are within the ISO 10816 or not, definitely the machine will run, but the life of the cutting tool will deteriorate, and this particular reduction in the tool life, reduction in the access and change in tool wear value, sharpness value is going to be reflected on the workpiece surface in the form of surface roughness. And if these 2 are ignored, automatically after quite some time, the cutting tool will fuse to the workpiece, because due to rubbing action, it will fuse to the workpiece. It's like a welding. Automatically, when welding is formed, it will not allow the workpiece, cutting tool to rotate. It automatically affects all the controls of the machine, not the controller. Inherent, inbuilt controls of the machine, it will affect the functionality of the servo motors. If the servo motor is stopped functioning, there is no need to go for any programming and all. So this much of damage can happen if we ignore the output process variables. The machine is trying to exhibit its acceptance or rejections at the earliest stage. If you are ready to listen to that, then go for the adaptive control. If you are not listen to the output process variables, then forget about the process monitoring. Nobody is going to question you. Again, you need to start approaching your authorities for procurement of the new machine. After 1 year or 2 years, again, that machine also will collapse. You are not allowing the machine to survive at least for its expected lifetime. If that is the objective, adopt the adaptive control system. And I'm suggesting the vibrations is because vibration signals are easy to quantify. There are many applications are available in the vibration signal analysis, not in the field of machining. You can take the literature of the vibration signal analysis in heavy machinery, turbines, blast furnace, generators, motors, etc., etc. The same logic can be applied here. Where there is a rotating member, you can apply the vibrations. Here, the rotating member, in case of milling and drilling, it is the rotating member is a cutter. In case of the turning, the rotating member will be the workpiece. So you need to look into that whether the object of your investigation, any of the object of your investigation is in rotating condition or not. If any of your object which is under investigation by you is in rotating condition, you can blindly follow the instructions of the ISO 10816. As part of this particular program, you need to make a, you need to be very comfortable with the MATLAB. Then only you can prepare the logic. These logic must be converted into bytecode. Then only the information will be transferred to the shared among the sensor, drive controller, and the machine controller. So that is what required. And we have selected this particular MATLAB code because before buying this particular equipment, we have verified the compatibility of this MATLAB code. That is a, you can say, hidden factor. But my intention is very much clear. My objective is clear before procuring the equipment. And we need to take, as a faculty, we need to take the best possible way to achieve the task. That is what the logical decision. Now, this is about algorithm. So, at what time, Rashagir, am I going out of the time?
It's good, sir. Going on. Good.
Okay. Okay. I have no problem, but if the participants are interested, I can take 10 to 15 minutes more.
Yeah. Please go on, sir. Please.
So, for every methodology, for every concept, you need to develop your own method. Then only this particular process, this particular algorithm, if it is implemented by any of the researcher who is going to attempt, who is going to repeat your task, it should yield consistent results. That is why you'll get the acceptance by the premier journals. So this is accepted by the International Journal of Automation Computing. They have validated this particular algorithm, and we were forced to share our MATLAB program also. Then only they have accepted this. So if anybody is ready to execute the same thing, in fact, if you want to repeat any good work from any research paper, we will end up in generating a new set of data. That is also considered research. There is no problem with it because the instrument used by me is different. The instruments are available with you at your end is different. But you are trying to repeat a process, an algorithm with your instruments. Based on your instruments least count or whatever the parameters you consider, whether the your instruments can be standardized or not standardized. This particular factor also can influence. So set of instruments is different, situation is different, the machine is different, cutting tools or whatever. There is a definite change in repeating the same task. If you are able to generate a data that is not similar with the data I have generated, if you are able to convert your data into a representation in a schematic way, that gives a understanding or interpretation of your results. If you are able to add your interest around the public graphs you have generated, you may end up in publishing a paper. So that is how I have published a few of my publications. Now, so coming to the real application, as I mentioned, adaptive control is going to act according to the sources of variables. It is having some set of solutions. When there is a specific situation comes into the picture, it is going to open that particular solution. That particular solution is, if there is an air gap is present, you implement the program number 1. You execute the program 1. When there is a no air gap, you select the program number 2. No, I'll give you one more example. All of you, please observe the middle figure, no air gap. When there is no air gap, you need to continue with the machining with the required feed rate because you need to remove the material. There is a requirement to remove the material. You should not change the feed rate. If you change the feed rate, it automatically uh, stops removing material from the start. Now, when there is an air gap, there is no need to maintain the same amount of feed rate. From this particular location, example, if the air gap started here, if it is ends here, there is no need to move with the predefined feed rate. You can reach it from this particular location to another location. End point of the starting point of the air gap to end point of the air gap can be moved in a bit faster than the required. Bit faster than the pre-programming. There is no need to maintain the same amount of feed rate. So if this is the situation, if the situation is identified, you can pick the different solutions. For air gap 1, when there is an air gap, one solution, one set of part program with one set of input parameters. When there is an air gap is present, change the value of feed in the part program. This particular instruction will be sent to the controller. And this particular information will be identified. Here, by simply observing the physical geometry of the workpiece, you can identify. This information is able to identify our eyesight because we are able to see. You can identify whether the air gap is there or not. How to transfer this particular information? I can understand there is no air gap, there is an air gap. But how to translate this particular understanding to the machine? There is no other way. We need to search a way so that you can identify a mechanism so that it can give a scope for transferring the information about whether the air gap is present or not. Now, that is done with the help of vibration signal. When there is material removal is taking place, definitely there is a 100% contact with the workpiece and the cutting tool. When there is a contact with the workpiece and cutting tool is taking place, is in very much in contact, automatically the vibration sensor is continuously collecting the data. When there is an interaction, is when there is no interaction between the workpiece and the cutting tool. In case of air gap, you can identify the vibration signal. There is a straight line in the vibration data collection console. It means it is not capturing the vibration. It is not finding any vibrations in the system. So that is how when there is a vibration is present, then this particular vibration will be translated or converted into quantified parameter. If the vibration levels are excessive, it will give reduce the feed rate or reduce the cutting speed. If the vibration levels are very much less, increase the feed to double or triple or 4 times the programmed feed rate. If I have used a feed rate as 40 as initial value, if the vibrations are not found in that particular cutting tool travel from one end to another end, then my system automatically suggests, because vibration levels are less than 1 or less than 2 or some cutoff value, it will automatically double the feed rate value. So that is how the vibration feedback is going to act as input parameters for changing the input instruction for the CNC machine. If the vibration levels when there is no air gap condition, again another set of solution. Vibration signals are present, you can continue the machining because the vibration levels what we have identified, they are well within the limits of ISO 10816 standard. As long as the vibration signals are within the guidelines of the ISO standard, there is no problem. You can continue the same input parameters for executing the task of machining cut 1, 2, 3, or 4, whatever may be. So, based on the excessive or lesser value, 2 different solutions. With the presence of the air gap, without presence of the air gap, another solution. Amount of the forces, another solution. Amount of the surface roughness, there is another solution. So like that, you can increase the complexity of the whole system. How exactly is going to work will be discussed, showed in the next slide. Now, this is about machining type, process setup. Everything can be given as an input, and this is where the vibration signal will be come into play. Now, so I'm taking the time, don't worry. Now, this is about initial time signal. You can identify the presence of the vibration in the system, and you cannot identify how much it is, and it is going to give the quantified signal. Now, I'm going to show with a MATLAB application. So all of you, can you see my screen?
Yes, sir. Yes, sir. It is visible, sir.
Okay. So it takes some time to process. Kindly cooperate with me because it is out of a DST project. If I'm able to generate some idea in any of the participants, it will be useful for me. I mean, it gives a lot of happiness to me. That is why I'm taking beyond time. I'm not hiding anything. I'm giving all the details. It is an open document. It is supported by the government of India, and it is my duty to give it back to the interested people. So I think it is taking time. Sir, can you help me how to do this?
Sir.
I'm trying to show the MATLAB application.
It is not visible, sir. You can share the screen, sir.
That is what
yeah, it is visible, sir, now. Sir, but some black patches are coming, sir.
Okay. Okay, 1 second. I'm closing down and ఒకసారి క్లోజ్ చేసి మళ్ళీ ఓపెన్ చేస్తాను.
Okay, sir.
This is last attempt. If it is not work, I'm going to go ahead.
Sir, still some problem is coming, sir.
Okay, I'll continue with the presentation.
Okay.
No problem. There is I have selected two options. I'll show the exact application of it. And this particular window is going to give the amount of quantity of the experimentation we have conducted. Identifying the vibration parameter is one thing, and identifying the when to implement the adaptive control logic is another thing. Vibration signal quantification is done with the help of fast Fourier transformation, and deciding about implementation of the adaptive control logic is done with the help of Hilbert-Horn transformation. So two different signal transformation functions are used. One is FFT transformation, another one is HST. These are popular applications, and HST is nowadays is most popular used for extensively for machining applications. One is for quantifying the signal, one is for logic implementation. So when cutting without milling vibration during the cutting, milling vibration when there is no material removal. Next. So Hilbert-Hanger transformation is used for the nonlinear applications. So most of the machining applications and high-speed machining generally involves nonlinear data. So this is where the Hilbert transformation is very much useful. I'll show you now. So you need to identify the which signal. First, initially, out of your collected signal, you need to decompose into more than 10 responses. So most of the cases, up to 5 responses, there will not be any change. Beyond 5, the system will started showing the differences. These deviations must be related with the decision making for implementation of the adaptive control system. Due to shortage of time, I could not focus on this because I need to show some live examples for this. I'm quickly going to the next step. Now, and this particular system, what we have developed is capable of taking AutoCAD drawing as an input parameter for this, automatically generates a part program. Based on the 2D drawing, it generates a part program. That is how we have developed. Once you're comfortable with some programming, anything can be done. Now, I was keep on mentioning about the one particular standard, ISO 10816 standard. This is the suggested guidelines for the different category of the machines. You can consider A, B, C, D. My machine, I have considered this particular machine, the range which is related to A. Because the machine I have worked which is fitting to the category guidelines of the A. It is working under 5,000, 20,000 RPM. Some horsepower constraint is there. Based on that, I have selected the guidelines associated with the category A. Now, if I'm able to project the MATLAB application with the help of this particular Zoom application, you could have a clear-cut idea about how exactly this particular MATLAB simulink is supposed to work. Then you can observe with ACC, with the adaptive control, and this is without adaptive control. And this process will take place less than 20 seconds on the controlling system, what we have used to operate the CNC machine. That is how we have developed a program. Everything, most of the programs are prepared with MATLAB and 20% from the AutoCAD. AutoCAD, AutoLisp, not the 2D drawings, AutoLisp. This is about measuring the judging parameter, that is tool wear. Now, these are the constants I have considered. Now, if you have remember the vibration severity charts, I have considered this particular standard. As long as the displacement values, I have considered the displacement parameter, depends upon my mathematical modeling. There is not a restriction to only to follow the displacement. Based on the LHS units matching, I have used this particular parameter. As long as the displacement values are less than 20 microns, there is no problem. You can continue the same input instructions. And the displacement are varying, found to be varying between 20 to 60 microns. When there is a displacement value beyond 60 microns, the machining is not allowed for further machining. And that is identified with the values of the flank wear also. As long as the flank wear values are less than 0.1 mm, that is correlates with the 20 microns situation. As long as the values of the flank wear are within the range of 0.1 to 0.3, the situation is similar to this particular vibration level. Whenever there is a vibration, this displacement value are found to be beyond 60 microns, automatically we found that the flank wear is beyond 0.3 mm. So that is why I had considered ISO 3685, ISO 8622 for judging the tool wear with respect to the multi-point cutting tool. If it is a single point cutting tool, ISO 3685. And these values are considered as a cutoff values with respect to rejection of the cutting tool, and these values are considered as a cutoff values with respect to the vibration signal. When there is deviation out of this particular group, you need to take a decision. So we were able to establish the logic with the help of FFT and HST, and I'm going to show the execution of this particular thing. So all of you please go through this particular video. This is without adaptive control. This particular right side video is with adaptive control. I'm going to switch on both the videos and you try to identify the difference. I'm going to discuss about this later. Now, again, I'm focusing the same slide. The video I have shown with adaptive control is able to complete its task. Even the same part geometry is used, is able to complete in quicker than this particular video. This particular operation, the same task is executed without the application of the adaptive control. It is ignoring the presence of the vibration. It is ignoring the presence of the air gap. When there is an air gap is found, even during the air gap also, this machining process, this particular video continues with the same amount of feed rate, same amount of depth of cut, same amount of the speed. Whereas in case of this particular video, with the same part geometry, it is able to double its feed rate when there is an air gap is identified. That is indicated with the help of presence of the vibration. When there is no amount of vibrations is identified, there is no need to continue with the same amount of input parameters. It can be, you can increase the feed rate. It can be 2 times or 3 times. It can be, definitely you can done. And that particular decision was made automatically. And that particular information is shared with the controller of the CNC machine with the help of presence of the vibration identification. So for your sake, I'm going to switch on the video again. Now, that is so the logic is developed only for one situation I have presented due to shortage of the time. But we were able to execute as per our plan, as per the targets. It is successful. It is still running in the Central Research Laboratory, GITAM. Most of my students will work in this particular lab. And this is the equipment I have purchased. And these are my team. They have worked under my guidance. And as a faculty, I always try to encourage my students. It's my passion also. Now, so I'm able to justify the logic with the help of vibration signals. I have used the vibration signals as a feedback. I'm able to regulate the input parameters without switching off the machine during the machining based on the, as far as possible, I have included nearly 5 to 6 different situations which comes under a sources of variables. I'm able to justify the logic with adaptive control, without adaptive control. And I have successfully completed this project. And this is supported by the SCRB, Department of Science and Technology. And he is my guru, Professor MMS Sarkar Garu, sorry. He's a retired professor at Andhra University. Unfortunately, my guru was expired during a road accident when he was a vice chancellor at JNTU Anantapur. Because of him, I am here. I learned so many things associated with my professor. So thank you everyone for giving this opportunity. Thank you, Dr. Rajshekar.
Thank you, sir. Thank you very much, sir. That was a wonderful and excellent presentation, sir. Prasad, sir.
Okay.
So you have given a very detailed presentation. People with zero knowledge also can gain such a knowledge, and definitely I wish like this could be of a great source to the people those are working on this area, and could help a lot in kicking start their research activity. Those who have not started their things, this could be of a great information with which they can start their research activities in this area. So that was a very excellent presentation, sir, on a trendy topic like starting with the machining, then computer numerically controlled machining, then connected to the vibrations, taking the feedback from the vibration for analyzing severity of the condition monitoring of the machine. That was an excellent, sir. Hope students and participants and researchers have enjoyed this, and this could help a lot to each and every one those who have participated in today's session. And once again, I wish to extend my heartfelt gratitudes to Dr. B.S. Prasad for being with us and accepting our proposal to be a part in this 5-day workshop. Thank you, sir. Thank you very much. And there was no questions. We were looking for questions. It's good.
Sorry for taking more time than the required, but
it's okay, sir.
I wish to complete
qualitative stuff never can't be measured with this time gap and all. So this definitely would help a lot to people. So
thank you, sir. Thank you. I want to say hello to all the participants, sir. I forgot to mention you regarding the panelists. I wish all the good luck to the participants. If you have any publications or anything related to this particular area, please do mail to me. My email ID is sballa@gitam.edu. Thank you, sir.
Thank you, sir. Thank you very much. Once again, gratitudes from the Department of Mechanical Engineering, GITAM University, Bangalore, and on behalf of AICT Atal Academy also. Okay, thank you, sir. Thank you very much, sir.
Thank you.
Thank you, sir.